All right, in section 7.4, we're looking at events that are mutually exclusive or not mutually exclusive. So what does it mean for two events to be mutually exclusive? This means that the two events can't or won't occur at the same time. So let's look at this first example real quick. It says 2 dice are rolled. What's the probability that the sum of the numbers rolled is either 3 or 7? So the two events are rolling a sum of 3 or rolling a sum of 7. These two events we say are mutually exclusive because they can't occur at the same time. I can't roll a sum of 3 and a roll of sum of 7 at the same time. So these two events are mutually exclusive. Why is that important? If two events are mutually exclusive, then the elements that are in their outcome, the outcomes that they have, won't have any overlap. So if I'm trying to find the probability of this event or this event occurring, we can just add up the number of times that the individual events could occur to get the probability. So that's what we'll be able to do here. So we're looking at rolling 2 dice and looking at their sum. So if I have 2 dice, then how many sums could I have? Well, on the first dice, there could be 6 different numbers, and on the second die, there could be 6 different numbers, which gives me a total of 36 sums. So remember, we're looking for a probability, so it is going to be a fraction. Bottom of the fraction is the total number of outcomes. So I know there's 36 total outcomes. How many of those would result in a sum of 3? How many in a sum of 7? So for 3, the first die could be a 1, and the second one could be a 2. That would give me a sum of 3. And the first one could be a 2, and the second could be a 1. That would give me a sum of 3. And so these are the only 2 ways that I could roll 2 die and get 2 dice and get a sum of 3. So for the event 3, there's 2 possible outcomes. So what about 7? You can pause for a second and see if you can come up with all the possible ways we could get a 7. So we're going to run through this the same way we did 3. I could have a 1 and a 6, and therefore a 6 and a 1. I could have a 2 and a 5 and a 2. I could have a 3 and a 4, or a 4 and a 3. If I switch this, I would get a 3 and a 4, and I'd just start my list back over again. So these are all the possible ways. 1, 2, 3, 4, 5, 6. So there are 6. So like I said, since these events are mutually exclusive, to find their probabilities, I just add up the number of outcomes for each one. So 2 plus 6 gives me 8. So the probability of rolling a sum of 3 or 7 is going to be 2 plus 6 over 36, which is 8 over 36. And Hawks, of course, is going to ask you for this either as a decimal or a fraction in lowest term. So they're both divisible by 4. I get 2 over 9. So the probability of rolling 2 dice, and getting a sum of 3 or 7 is 2 9s. All right, so let's go to the next problem. It says a bag of, next problem. Okay, a bag of 11 marbles contains 5 marbles with red on them, 3 with blue, 7 with green, and 4 with red and green. What is the probability that a randomly chosen marble has either green or red on it? So kind of the same situation as above. We do have a set of outcomes, and we're trying to figure out the probability of one event or the other occurring. Go back to our understanding of logic. Or means one, the other, or it could be both. And our 2 events are green, having a marble with green on it, and having a marble with red on it. So are these 2 events mutually exclusive? So if we come up here, it says 4 with red and green on it. That's kind of a dead giveaway that these 2 events aren't mutually exclusive. So what does that mean in other words? There are marbles where both of these events occur. It has both red and green on it. So these 2 events are not mutually exclusive. Obviously, there's some overlap. So we have to account for that overlap. Another thing you can see, we know there's only 11 marbles in the bag, but if you go up and add how many marbles they're talking about, we get 3 and 7, that's 10, 15, 19 marbles are listed off here, but there's only 11. So obviously this is talking about some overlap. We're only talking about the red and the green marbles. So I'm going to come down here and use a little bit of my set understanding. So my Venn diagram. So there's definitely different ways that you could do this, but I'm going to let these be my red marbles, these be my green marbles. We know that there's 4 with both red and green on it, so 4 is going to go in that intersection. There's total 5 marbles that have red on them. If the whole circle is talking about the marbles that have red, and I know that should add up to 5, and there's 4 in the intersection, that tells me there's only actually 1 marble that has just red on it. And likewise with the green, this whole circle is talking about the marbles that have green on them. We know there's 7 of those. So this circle should add up to 7. I already have 4 in the intersection, so that means there are just 3 green marbles. So now knowing that and seeing where the overlap is, I know that there are 1, 5, 8 marbles that have red, green, or both on them. So the probability of reaching into this bag of 11 marbles and grabbing one that has green or red on it is going to be 8. So there's 8 of them out of all 11. So the probability of this event or this event occurring is 8 out of 11. Alright, so let's do one more. So we have this set of students. We have freshmen through senior. One's living on, and grad students. One's living on campus and one's living off of campus. And we want to know, if we just randomly picked a student, what's the probability that we would choose a member, I think this is talking about student council, that is a senior or lives in off-campus housing. So we're talking about seniors, so we're looking at this row right here, there's 6 of them. And we're talking about students in off-campus housing, so we're looking at this column right here, which again, there's 6 of them, but notice these 3 are overlapped. These are seniors that live off campus. So if we just did the 6 and the 6, we are counting them twice, meaning these events are not mutually exclusive. Seniors and students living in off-campus housing have an overlap, and we see that right here. These are seniors that live off campus. So we can only count these once. So for seniors, I can count them in seniors or I can count them in off campus, but I just need to add up the total. So there's 3 seniors that live on campus, 3 that live off campus, and then there's 1, 2, 3 other students that also live off campus. So total, how many students am I talking about that are either seniors or off campus or both? I have 3, 6, 7, 8, 9. So 9 outcomes of students that are seniors or live off campus. This is a probability, so I need the total number of outcomes, which means all the students we're talking about. So for those living on campus, I have 3, 6, 10, 11. Those living off campus, I have 6, so there's 17. So I have 9 out of 17 probability of, if I randomly picked a student, I would get one that was a senior or one that lives off campus, or the implied both.